Okay, in this video we're going to look at part 6 of the review, looking for properties of a rational function. We're looking for domain, zeros, asymptotes, and end behavior. Okay, rational function is, these are the two examples. This is something where we have a variable in the numerator and denominator of this function. The first step on doing this is to take the problem and try to factor any piece possible. So the numerator on the first one doesn't factor, but the denominator does. So we'll look at that as x minus 3 and x plus 3, so that we can look for domains and asymptotes. So if we're looking at this function, the domain of this is going to be anywhere except when the denominator is 0. So domain bx is except x minus 3 is not equal to 0 and x plus 3 is not equal to 0. So here the domain is x is not equal to 3 and x is not equal to negative 3. So if we write that, if we wrote that in, that's writing it in set notation, we can do that way, or we can write it with interval notation. That means we're going to start at negative 3. We're going to go, we're going to start at negative infinity. Starting at negative infinity, we're going to go up to negative 3. We're going to not include negative 3, so we'll put an open parentheses there. Then we'll go from negative 3 to positive 3, and then we'll finish by going from 3 to infinity. So that would be the domain written in interval notation. The zeros of this problem is when it's either when we put 0 in for r of x. So we're going to have 0 equals x plus 2 over x squared minus 9. So that's going to be, if we multiply through by the denominator, we're going to get this side will reduce out. This side is going to still be 0, because you have 0 times that, so we're still going to have 0 there. So x plus 2 equals 0, so x is going to be negative 2. That's going to be a 0 of this function. So negative 2 comma 0 is the 0 of this function. This is your domain. And we're going to look now at asymptotes. Now asymptotes, we have 3 types: vertical, horizontal, or oblique. Now you can only do oblique or horizontal. You can't do both, and that is based on powers here of the lead terms. So let's look at vertical asymptotes first. Vertical asymptotes happen after this has been factored and reduced. So we can't reduce that at all. So we're going to be looking for vertical asymptotes when the denominator equals 0. So vertical asymptotes when the denominator, x minus 3 and x plus 3 equals 0. So it's the same, it's basically very similar to finding the domain. So the vertical asymptotes here are going to be x minus 3 equals 0, or x equals 3, and x plus 3 equals 0, or x equals negative 3. So these are the vertical asymptotes. The horizontal or oblique asymptotes happen when we look at the exponents on the lead terms. So here are our exponents on the lead terms. We look at this part right here. Since the denominator power is larger than the numerator power, that means that you don't have an oblique. Oblique is when the powers are the same. This means power is larger here, so that's going to mean that we have a horizontal one at y equals 0. Horizontal asymptote y equals 0. That occurs when the denominator exponent is larger than the numerator exponent. Okay, and finally, end behavior. End behavior is what happens to the function as x gets larger or smaller. So as x gets larger, what happens to r of x here in this case? I think that's what it is, r of x, yep. What happens to r of x? So this is end behavior. What happens to the function as x gets larger, as x gets smaller, negative infinity? What happens to r of x also? We want to know what happens to it. Where does it go? R of x goes somewhere. How high does it go on the graph? Now we could graph this to look at this function, but since we have a horizontal asymptote, that's where it's going to approach. As we get bigger, it should approach the horizontal asymptote. So in this case, both sides should approach 0 because of the horizontal asymptote. All right, let's look at the second example. We're going to do the same information here. I'm going to factor. So the numerator factors into x plus 2 and x plus 1. And the denominator is, since already factored, into x plus 2 squared, which means x plus 2 and x plus 2. Now this domain is only restricted by, since this is the same, one of these two terms. So in here, x plus 2 cannot equal 0. So x cannot equal to negative 2. So we would have a domain of negative infinity to negative 2, and from negative 2 to infinity, not including negative 2. That would be your domain in this function. A 0 would be when the top part is 0. So that would be when x plus 2 equals 0 and x plus 1 equals 0. That would be your zeros. And the first one gives you x equals negative 2, but that's not in the domain. We already just stated that. So that is not a 0 because it's not in the domain. And the second one, x equals negative 1. This would be our 0 that is in the domain. We can't use this one because it's not in the domain. So our 0 in this case is negative 1 comma 0 in the second example. And our asymptotes here are vertical. We're going to have a vertical one at x equals negative 2, vertical asymptote. because of the denominator, vertical at x equals -2, and we just did that up here, right here actually, in the domain. We said it couldn't equal -2, so that's going to be our vertical asymptote. And we have a horizontal asymptote since the powers are actually the same. So if we were to look at this in terms of this is an x squared, if we multiply this out, because we have to look at the original problem as if it was already factored or already multiplied out. So this denominator is really x squared plus 4x plus 4. If we were to do FOIL on this, if we were to multiply x plus 2 times x plus 2, we would get this denominator. That means that the powers here, the exponents on the numerator and denominator, are the same for the lead terms. And if they are, we divide those two to find the horizontal asymptote. So the horizontal asymptote is where we have y equals your lead terms divided. If they're the same, you divide the lead terms and they're both x squared, so that's going to give us a horizontal asymptote at y equals 1. And the final thing here, end behavior. Since we have a horizontal asymptote at y equals 1, our end behavior, similarly to this one, our end behavior is going to be as x approaches infinity. Your function in this case was capital R of x here still. Capital R of x is going to approach 1 because of the horizontal asymptote. As x approaches negative infinity, R of x approaches 1 on the other side as well. Now if we don't have a horizontal asymptote, then these could be going to infinity or negative infinity. If we have an oblique asymptote, that's what's going to happen. So otherwise we'll approach these asymptotes on both sides for these rational functions. All right, that's different than polynomial functions. All right, so that's problem 6.